Today, China is making a strong push to capture the global automotive market from Western countries. It is developing new innovations that could completely reshape the future of transportation. Imagine an engine that is not only highly powerful, but also extremely cost-effective. So much so that even the biggest electric vehicle companies might start to worry about their dominance. This idea isn't some far-off dream or a concept gathering dust in a laboratory. The technology is getting ready to hit the roads, and its journey begins in China. While many Western companies are still trying to reduce costs and improve battery performance, this new engine is quietly preparing to change the entire game. But the real question is this engine powerful enough to disrupt the strategies of major companies like Tesla, BYD, and other automotive giants? Will electric vehicles truly remain the ultimate solution for the future of transportation? Or could this new technology reshape the entire industry? In today's video, we'll uncover the real story behind this engine, explore the technology China is using, and see why it's surprising the global automotive sector. Make sure to watch the video until the end. And before we continue, don't forget to subscribe to the channel so you never miss videos like this. If you attend any major auto show in the world today, one thing becomes clear. The story of electric vehicles is not just about technology, it's also about strategy. And in this strategic race, China positioned itself as a leader much earlier than many people realize. China didn't simply enter the EV market by manufacturing electric cars. Instead, it built the entire ecosystem around them. Today, many other countries are struggling to maintain their position, while China has already moved several steps ahead. However, this transformation did not happen overnight. Around 20 to 25 years ago, major Chinese cities were facing severe pollution problems. Thick smog covered cities like Beijing and Shanghai, and air quality had become a serious concern. At the same time, China's heavy reliance on imported oil was putting pressure on its economy. The government realized that if the country wanted to secure its future, it needed to transform its energy system. That realization led to a long-term vision focused on electric mobility. In the early days, very few people believed that electric cars could become mainstream. Batteries were expensive, driving range was limited, and charging infrastructure was almost non-existent. Despite these challenges, the Chinese government decided to take the risk. In 2001, under the 863 program, China began investing heavily in clean technologies and advanced research sectors. Later, the New Energy Vehicle (NEV) policy was introduced to promote battery electric vehicles, plug-in hybrids, and fuel cell vehicles. Consumers were offered subsidies, companies received tax benefits, and gradually, the entire market environment started to shift. One of the most interesting strategies China adopted was focusing on electrifying public transportation before encouraging mass adoption of private EVs. The city of Shenzhen is a perfect example of this approach. The city set an ambitious goal to convert its entire bus fleet to electric. By 2017, Shenzhen had successfully transformed nearly 16,000 buses into electric vehicles. This wasn't just a local achievement. It sent a powerful message to the world that large-scale electrification was possible. The shift helped reduce pollution and inspired other cities to follow a similar path. Another major step came in 2017 with the introduction of the dual credit system. Under this policy, automakers were required to produce a certain number of electric vehicles. If they failed to meet the target, they had to purchase credits from other companies that exceeded their quotas. This system left car manufacturers with only two options: produce electric vehicles or face financial losses. As a result, local brands expanded rapidly, production increased, and costs began to fall. At the same time, China built another powerful advantage: its charging infrastructure. Today, the country has millions of charging stations spread across cities and highways. In many major cities, finding a charging point is now almost as easy as finding a petrol station. This widespread infrastructure significantly reduced the fear of range anxiety, which had been one of the biggest concerns for potential EV buyers. When people feel confident that they can easily find a place to charge their vehicle, they are much more willing to switch to electric cars. China first built that confidence by developing the infrastructure, and only then pushed large-scale vehicle adoption. And finally, we come to the most critical component of any electric vehicle, the battery. The battery is essentially the lifeblood of an EV, and this is another area where China has established a strong advantage. Companies such as CATL and BYD not only supply batteries within China, but also export them to Europe and the United States. When a country controls both battery manufacturing and the supply chain, its influence across the entire automotive industry naturally becomes much stronger. This is why China's strategy goes far beyond simply manufacturing cars. The country has built control over the entire supply chain, from raw materials to the final vehicle. Because of this approach, electric vehicles now make up nearly 40% of new car sales in China. Just a few years ago, such a number seemed almost impossible. However, focused policies, government subsidies, and massive investments have turned that vision into reality. Today, Chinese automakers are no longer focused only on their domestic market. They are expanding quickly into international markets across Europe, Latin America, and Asia. In many of these regions, they are directly competing with long-established global brands. Now let's talk about one of the most interesting developments, China's powerful electric motor technology. Imagine an EV motor that is not only extremely powerful, but also affordable enough to shake up the entire electric vehicle industry. Before diving into that technology, it's important to understand the company behind much of this progress, BYD. This company is playing a huge role in reshaping the automotive industry in China. BYD is not a typical car manufacturer. Instead of just assembling vehicles, the company produces many of the critical components itself, including batteries, motors, control systems, and other key technologies. This approach is one of its greatest advantages. When a company manages everything from battery production to final vehicle assembly, costs naturally decrease. Lower costs make it much easier to offer vehicles at affordable prices. So how exactly is BYD able to launch electric cars at such competitive prices? The first reason is vertical integration. Many automakers rely on external suppliers for batteries, motors, and other major components, and then assemble the car elsewhere. BYD, however, manufactures many of these parts internally. A great example is BYD's well-known Blade battery. This battery uses LFP, lithium iron phosphate technology. Unlike some other battery types, it does not rely on expensive materials such as cobalt, which helps keep production costs lower. At the same time, this battery design is considered safer because it is less likely to catch fire. Another key factor is scale. BYD produces vehicles in extremely large numbers. When production increases to that level, the cost per unit naturally decreases. This allows the company to offer electric vehicles even in the budget segment without removing important features. Now let's look at the powerful motor technology that has been attracting so much attention. BYD vehicles use permanent magnet synchronous motors, PMSM. These motors are capable of delivering high power and torque while remaining compact in size. One of the biggest advantages of electric motors is instant torque. In traditional petrol or diesel engines, power builds gradually as the engine revs up. But in an electric vehicle, full torque is available immediately when the driver presses the accelerator. This is why many BYD models can accelerate from 0 to 100 kilometers per hour in just a few seconds, sometimes even faster than many gasoline-powered cars. Take the BYD Seal as an example. Its dual-motor version produces enough power to deliver performance similar to a sports sedan. It combines quick acceleration, stable handling, and an impressive driving range. Another popular model is the BYD Auto 3. This SUV is designed for families and offers a comfortable driving experience while still providing strong performance. It works well both in city driving and on highways. In the more affordable segment, there is the BYD Seagull. Despite its compact size and low price, the vehicle still offers a capable motor that performs well for everyday driving. So the big question is, can these electric motors really outperform gasoline engines? In many cases, the answer is yes. Gasoline engines depend on complex systems like gear shifts, RPM ranges, and power curves to deliver performance. Electric motors, on the other hand, provide direct and instant power with far fewer moving parts. This also means less energy loss during operation. Because of this efficiency, even a relatively small electric motor can deliver performance that matches, or sometimes exceeds, a much larger gasoline engine. Another area where BYD has focused heavily is electronic control systems. Components like inverters and power management systems are carefully optimized to ensure that the motor delivers maximum performance at the right time. In addition, BYD's advanced E-Platform 3.0 integrates the battery, motor, and chassis into a single optimized system. This design reduces overall weight, improves balance, and increases energy efficiency. To simplify the comparison between three of BYD's popular models, the Seagull is designed for buyers who want a compact and affordable EV, mainly for city driving. The Auto 3 serves as a mid-range family SUV, offering more space, comfort, and versatility. The Seal is aimed at drivers who want a stylish vehicle that also delivers strong speed and performance. While these vehicles serve different purposes, they all share the same core technology foundation. The main differences lie in power levels, size, and features tailored to different customer needs. Ultimately, the secret behind BYD's rapid success isn't just low pricing. It's the combination of advanced technology, massive production scale, and full control over its supply chain. This powerful mix allows the company to produce electric motors and vehicles at prices that are highly competitive, while still delivering performance that can rival or even surpass many traditional gasoline-powered cars. This development has become a serious challenge for the global EV industry. When it comes to battery technology, China is not just participating in the competition, it is working hard to lead it. Over the past 15 to 20 years, China has invested enormous resources into research, development, and manufacturing of electric vehicle batteries. Very few countries have committed to this sector at such a large scale. To understand China's approach, it's important to realize that the country does not treat batteries as just another vehicle component. Instead, batteries are considered the foundation of the entire EV industry. In an electric vehicle, the real strength comes from the battery rather than the motor. Factors such as driving range, vehicle cost, safety, and performance all depend heavily on battery technology. Because of this, China began focusing on battery production from the very beginning of its EV strategy. Today, one of the world's largest battery manufacturers is CATL, a Chinese company that supplies batteries to many global automakers. Similarly, BYD also produces its own batteries in-house. China has worked on two key objectives in this field: lowering costs and improving technology. A good example of this effort is the development of LFP batteries, which stands for lithium iron phosphate. In the past, many companies relied heavily on NMC batteries, which are made from nickel, manganese, and cobalt. These materials, especially cobalt, are expensive and relatively scarce. China focused on improving LFP battery technology, making it both more affordable and safer. LFP batteries are known to be more resistant to overheating, which reduces the risk of fires. Because of these advantages, their use in mainstream electric vehicles has increased significantly in recent years. Another important step China took was gaining strong control over the battery supply chain. Producing batteries requires more than just factories. It also requires access to critical raw materials like lithium, graphite, and other minerals. To secure these resources, China invested in mining projects across regions such as Africa and South America. These investments helped ensure that raw materials could flow directly into Chinese manufacturing networks. As a result, China gained greater control over both supply stability and production costs. Research and innovation are also major priorities. Many Chinese companies are currently working on the development of solid-state batteries. These are widely considered the next generation of battery technology because they could offer higher energy density and significantly faster charging times. Although this technology has not yet been fully commercialized, China is making rapid progress in this area. At the same time, companies are developing advanced fast-charging solutions. The goal is to create batteries that can recharge large amounts of energy within just 10 to 15 minutes, making EV charging almost as convenient as refueling a traditional car. Another key factor behind China's progress is production scale. China not only developed the technology, but also implemented it on a massive industrial scale. Large battery gigafactories with enormous production capacity have been built across the country. When production reaches such high levels, the cost of each battery unit naturally decreases. This is one of the main reasons why electric vehicles produced in China often appear more affordable than those from many competitors. Government support has also played a major role in this success. Subsidies, tax incentives, and significant research funding allowed companies to take risks and continue innovating. Even during the early years when battery technology was expensive and uncertain, these companies were able to survive and grow because of strong government backing. However, there is another side to the story that is not always discussed when people talk about electric vehicles: the environmental cost of producing EV batteries. Electric vehicles are often promoted as a solution to reduce pollution, eliminate the need for petrol and diesel, and help fight climate change. In many ways, this is true. EVs can significantly reduce emissions during daily use. But the production of their batteries also comes with environmental challenges. The core of every electric vehicle is its battery, and manufacturing that battery requires minerals such as lithium, cobalt, and nickel. These materials must be extracted from the earth through mining operations. While it may sound simple, the process is actually complex and extremely resource-intensive. For example, extracting lithium requires a huge amount of water. In some regions, millions of liters of water are needed to produce just 1 ton of lithium. In areas that already face water shortages, this heavy water use can directly affect local communities and agriculture. Similar issues have been observed in parts of South America, as well as certain regions in China. Another important mineral is cobalt. A large share of the world's cobalt supply comes from the Democratic Republic of the Congo in Africa. Mining operations there have been linked to environmental damage such as deforestation, soil degradation, and water pollution. This means that while electric vehicles themselves do not produce exhaust emissions, the manufacturing of their batteries cannot be considered completely environmentally neutral. China's role in this situation is significant because it dominates global battery production. Companies like CATL and BYD supply batteries to EV manufacturers all over the world. When production operates at such a large scale, the demand for raw materials also increases dramatically. As demand grows, pressure on mining operations grows as well. However, the industry is not ignoring these concerns. One promising solution is battery recycling. In China, several large recycling facilities have been built to recover valuable materials such as lithium and other metals from used EV batteries. By reusing these materials, companies can reduce the need for new mining while also making battery production more sustainable in the long term. One of the main goals is to create a closed-loop system. In this system, materials recovered from old batteries are reused to produce new batteries. This approach can reduce the need for fresh mining to some extent. However, it is not a complete solution. The demand for electric vehicles is increasing so rapidly that recycling alone cannot meet the growing need for battery materials. Another promising idea being explored is the use of second-life batteries. Even when an EV battery no longer provides enough power for a vehicle, it doesn't become completely useless. In China, researchers and companies are experimenting with using these retired batteries in large energy storage systems. These systems can store electricity generated from renewable sources such as solar and wind power. By repurposing old batteries in this way, their lifespan can be extended and the pressure on raw material extraction can be reduced. Environmental concerns are not the only issue connected to battery production. Labor conditions associated with mining, especially cobalt mining, have also become a serious concern. A significant portion of the world's cobalt supply comes from the Democratic Republic of the Congo, where reports have repeatedly highlighted problems such as unsafe working conditions and even child labor. As the global shift toward electric vehicles accelerates, an important question arises. Could this transition also carry hidden human costs? Because of these concerns, governments, companies, and organizations involved in the battery supply chain are now under increasing pressure to ensure transparency and adopt responsible sourcing practices. Many Chinese companies are already trying to reduce their reliance on cobalt. One important step in this direction is the growing use of LFP, lithium iron phosphate batteries, which do not require cobalt at all. This change not only lowers costs, but also reduces dependence on a controversial and ethically challenging resource. Still, the reality remains complicated. As the demand for electric vehicles continues to grow rapidly, so does the demand for natural resources. Every new electric car means additional mining, greater water consumption, and increased pressure on the regions where these minerals are extracted. Most electric vehicles currently use lithium-ion batteries. These batteries perform well, but they also have certain limitations. Charging times can be long, safety risks exist under extreme conditions, and the driving range is still limited compared to traditional fuel vehicles. This is where solid-state batteries come into the picture, and China is rapidly investing in this technology. To understand this innovation, we first need to know what makes a solid-state battery different. Conventional batteries contain a liquid electrolyte, which is a chemical liquid that allows electric current to move between the battery's components. In solid-state batteries, this liquid is replaced by a solid material that performs the same function. At first glance, this may seem like a small change, but in reality, it can lead to major improvements in battery performance. One of the biggest advantages is higher energy density. This means that a battery of the same size can store significantly more energy. If this technology becomes widely successful, the driving range of electric vehicles could increase dramatically. While many EVs today offer ranges of around 400 to 500 kilometers, solid-state batteries could potentially allow ranges of 700 to 800 kilometers or even more. Such improvements could greatly reduce one of the biggest concerns of EV buyers, range anxiety. Safety is another important benefit. Batteries that use liquid electrolytes can sometimes overheat or catch fire, especially in cases of accidents or electrical faults. Solid electrolytes are generally more stable, which could reduce these risks and make the batteries safer overall. Now the question is, where does China stand in this race? China is already a global leader in battery manufacturing. Companies like CATL and BYD play a major role in producing lithium-ion batteries for electric vehicles around the world. Today, These companies, along with several emerging startups, are actively researching and developing solid-state battery technology. The Chinese government is also providing funding and policy support for this research. The country understands that mastering next-generation battery technology could further strengthen its leadership in the EV industry. China's strategy goes beyond laboratory experiments. The goal is to bring solid-state batteries into commercial production as quickly as possible. This means moving beyond prototypes and developing the ability to produce these batteries on a large industrial scale. Scale has always been one of China's biggest strengths. When a new technology reaches mass production, the cost often drops significantly. However, it is important to remember that solid-state batteries are still in the development stage. Several challenges remain. The materials used in these batteries are currently expensive, the manufacturing process is complex, and the long-term durability of the technology still needs further testing. Despite these challenges, research continues to move forward. Some reports suggest that vehicles equipped with solid-state batteries could begin appearing in limited numbers within the next few years. At first, these vehicles will likely be expensive, but if China manages to produce the technology at a large scale, prices could gradually decrease, similar to what happened with lithium-ion batteries. The potential advantages of solid-state batteries go beyond range and safety. They could also make electric vehicles lighter and more compact while delivering greater power. This could improve vehicle performance, enabling faster acceleration, better balance, and shorter charging times. When we look at the bigger picture, solid-state batteries represent not just a technological advancement, but also a strategic opportunity for China. Countries such as the United States, Japan, and several European nations are all competing in the EV industry. But if China succeeds in leading the development and production of next-generation batteries, its global influence in the automotive sector could become even stronger. Solid-state batteries could become the next major milestone in the evolution of electric vehicles, and China is working to reach that milestone first, and on a massive scale. The race is still ongoing, but if China successfully repeats the strategy that helped it dominate lithium-ion battery production, combining research, government support, and large-scale manufacturing, the next chapter of EV technology could very well belong to China. If you want to keep learning about powerful developments in technology and electric vehicles explained in simple language, make sure to subscribe to the channel so you never miss the latest updates and stay ahead of the curve.